So if we have a look at the proton-proton chain series of reactions, this is what happens in smaller stars up to about 1.3 solar masses. So 1 solar mass is the mass of our sun. It's pretty easy. So this is what happens in our sun, basically. So there's a few steps, so we'll go through those. And I've got them as like the equations here, and I've also got a diagram for you, so we'll try to explain both. So first step, you've got 2 protons and they smash into each other. So you've got a H and a H, and the atomic mass of those is both 1 because they're just made of a proton each. So that's all they're just a single stripped proton. Remember, it's like a plasma ball. They're just flying around in there. It's high temperature. They're going crazy. They happen to collide. The pressure in there is enough to overcome the electrostatic repulsive forces between them. They join together. Okay, but it's not as simple as that, because you don't just end up with 2 protons then. What happens is one of the protons turns to a neutron. But a neutron has no charge. So what happened to the positive charge? Well, something called a positron, which I think we've talked about in the last lesson, it gets ejected. So it's basically shown as an E with a plus because it's like an electron, but it has a positive charge. So you know now that, that electrons have a very, very small mass. So basically that proton can turn into a neutron and a positron. So basically what you're getting there is like a balance of the charges. And the other thing you're getting chucked out then is a neutrino, which is like this really short-lived particle. So we'll talk about those when we look at the standard model and things later on when it gets crazy. So first step, you can see in the diagram as well that you've got 2 of those protons. So like 2 basically like single proton, no neutrons, hydrogen nuclei, I guess you could think of them as, smashing together, chucking out a positron and a neutrino and forming a proton and a neutron pair. And we call that deuterium. And it's known as heavy hydrogen because it's like it has an atomic mass of 2 because it has a proton plus a neutron. It's not just a single proton. Okay, so that basically happens twice. So you get 2 of those happening, and that's why you've got that here. You've got like it happening a second time. Okay, so just below it. So this has to happen separately twice, and then you end up with 2 deuteriums, which means obviously you've got 2 positrons and 2 neutrinos. All right, so let's think about one of these deuteriums first of all. So basically what happens to it then, how do we make it into helium? Well, we crash another proton into it. So when we crash the extra proton into it, and you can see it coming in from below there, and you can see it in that second equation, you've got the 2H, so that's the deuterium with the proton and the neutron, and then you add on just the hydrogen that's just the proton, and you end up with an atomic mass of 3. 2 of those are protons now, and you've got your neutron. So that's now helium because it has 2 protons, and we know that the number of protons determines which element it is. So we've now made helium, but it's not normal helium yet. We're not finished. Now, when we do this, it releases a lot of energy. This is, so obviously the sun's releasing energy. It's luckily, yeah. And so we can see that we're also producing a gamma ray at that point. And we can see that in the diagram. So you can see when that proton smashes in from the top and the bottom. So this is once again happening to both deuteriums. We're getting a gamma ray flying off, and we are getting now a nuclei that has 2 protons and 1 neutron. And what happens to that gamma ray? Well, it's being made in the core. It's going to go out through all of those layers of the sun, taking 170,000 years, changing on the way, so losing energy on the way to become a longer wavelength generally. And some of it will eventually reach Earth, which is a lovely story. Okay, so now we've got these weird heliums that have 2 protons and a neutron. We're not there yet because we need to have a normal helium atom. So what do? We get 1 of these heliums, and we get another one of these, like 3 heliums, like so the 2 proton and 1 neutron heliums, and we just smash those together, okay? So we smash them together, and out of that we end up with a helium atom that has what we would expect, which is 2 protons and 2 neutrons. And we also end up with a couple of extra protons. And those protons can go on and, form, like, be part of the next proton-proton chain reaction, which is kind of cool. So one of these chains to finally produce that 4 atomic weight helium. So like 1 helium molecule, 1 helium nucleus, and 2 protons. That basically produces 26.72 mega electron volts. And that's the process that powers our sun.